So hope you have tried out most of the questions of worksheet 4, though we'll be discussing many of them here today. So let's start with the recap of the important things we saw in lecture 4 before we come to that. So in the recap, what I want to stress on is the geometrical properties that we saw towards the end. So we saw what we call the triangle inequalities. So we will see very soon the application of these triangle inequalities in certain types of questions. So basically that comes from the triangle laws, both the parts, whether we are doing vector E plus B or we are doing vector E minus of B. So this is a vector E and this is another vector B, and the angle between them is theta like this. And we can see over here that in this triangle, which I am drawing to the left, we are calculating the sum of the two. So this is called that particular triangle. The triangle which gives us the resultant of the two vectors. And this particular angle we call alpha. And the second one is where we are calculating what we call the difference, because here what we are summing up is vector E but with minus of the vector B. As you can see here, if I were to draw this perfectly, then this vector here is exactly negative of that vector over there. So this is the vector which we would call minus B, given that vector E was like this and vector B was like this. So if I am to involve these two vectors in a sum triangle, it would be this triangle, whereas if I am to involve them in a difference triangle, then it would be this one, where the angle between the vector A and negative of the vector B would in fact become this exterior angle, which is 180 minus theta. And then we saw that by application of the same principle over here, we can calculate the difference as this vector. This becomes the difference of A and B. So this particular vector becomes what we call A plus of minus B or A minus B. And this particular angle becomes over here what we call beta. So we have the formula related to these triangles. So let's quickly refresh the formula. So A plus B, you must be very used to this by now. The magnitude of A plus B, or the resultant, is root of A square plus B square plus 2AB cos theta. And that angle alpha is such that tan alpha is B sin theta divided by E plus B cos theta. Whereas in the second one, we can see the magnitude of A minus B. After doing all that application and derivation and all, it turned out to be this formula: root of A square plus B square minus 2AB cos theta. And this is what we saw towards the end of last lecture. And that angle beta here, this one, the angle that the vector A minus B, this vector is making with respect to the angle, the vector E, that angle over here, this angle beta. So this angle beta, it became such that tan beta is B sin theta divided by E minus B cos theta. So one easy way to remember is that the relationship between this one and this one, everywhere where there's plus cos theta here, replace it with a minus cos theta. So you get the difference on a triangle. Okay? So we also saw later that these two triangles can be combined to form the vector parallelogram. But before that, we saw that since cos theta cannot go greater than plus 1 and cannot go less than minus 1. So it happens to be plus 1 when theta is equal to 0, and it happens to be minus 1 when theta is equal to 180 degrees, which we have understood from trigonometry in 4 quadrants, that cos 180 is minus 1, whereas cos 0 is plus 1. So you can see that if you now, for example, concentrate on this expression here, this one. So you can see that A plus B का maximum value क्या हो सकता है? A plus B के magnitude's maximum value is when cos theta is maximum here, and that is equal to when cos theta becomes plus 1, because that's the maximum possible value. So correspondingly, we saw that if we analyze the magnitude of A plus B, it cannot exceed the maximum value that this magnitude or resultant can have is when cos theta is 1. So that is when at that point of time it becomes A plus B. It becomes the magnitude of A plus the magnitude of B. But as you can see, the moment you put theta is 0 or cos theta is 1, this quantity becomes A plus B whole square root, that is nothing but A plus B. And similarly, the minimum value corresponds to when cos theta is minus 1. And that time the quantity inside the square root becomes A minus B ka whole square. So this just becomes the difference of A minus B. So the resultant's maximum possible value is A plus B and the minimum possible value is A minus B. But that happens when theta is 0. This happens when theta is 180 degrees. And for all other thetas, it is somewhere in between these two values. Okay? Now similarly, if you look at also the expression of A minus B is resultant. I mean the difference of A minus B. Even here you can see it depends on cos theta. But यहाँ पे क्या हो रहा है, उल्टा हो जा रहा है. When cos theta is positive of 1, this quantity is actually becoming minimum. It's becoming A minus B. So the difference of two vectors has a minimum value, which is the difference of their magnitudes if they happen to be parallel vectors. That is theta is 0. Because on the other hand, whenever cos theta is becoming minus 1, the quantity inside the square root is actually becoming maximum because this cos theta is minus 1, so it is becoming plus 2ab. So that means the difference of two vectors has the maximum magnitude when they are which type of vectors? They are anti-parallel or theta is 180. So even A minus B has a similar kind of a inequality relationship. So A minus B has the similar kind of inequality relationship that even this has the maximum possible value of A plus B. But the difference is when is the difference having a magnitude which is the sum of this, that is when theta is 180 or they are anti-parallel vectors. Whereas when they are anti-parallel, the sum is having the minimum value, the difference is having the maximum value. And similarly vice versa for this. The difference will become A minus B is mod when they are parallel vectors, whereas the sum will become A plus B when they are anti-parallel vectors. So these two collectively you can say they are called the triangle inequalities. This we discussed in detail last time, this I am just introducing for you right now. So you can understand it's the same logic over there, but this is applied to the second formula, which is for the difference, whereas the first one was applied to this formula, which is for the sum. Okay. So that was one thing that we saw. The other inequality that we saw for the sum is that mod of A plus B, this quantity becomes greater than root of A square plus B square if theta is acute, so less than 90 degrees. Okay, so theta is acute means basically what is happening, cos theta is becoming a positive quantity. So if cos theta is positive, so you can see in the formula for mod A plus B, you can see in the formula of mod A plus B, if cos theta is positive, then the quantity inside the square root is becoming more than root of A square plus B square. Whereas if cos theta is negative, the quantity is becoming less than root of A square plus B square. And if cos theta is 0 exactly, then it becomes a hypotenuse. So mod of A plus B can become exactly equal to root of A square plus B square also. But for that, the vectors have to be perpendicular. So theta has to be 90 degrees. For this condition, theta has to be less than 90. It has to be acute. And similarly, when theta becomes obtuse, cos theta becomes negative. So this quantity actually becomes less than root of A square plus B square whenever theta is greater than 90, or it is an obtuse angle. So cos theta becomes negative. So these are three additional little concepts that you can keep in mind. The main one is the triangle inequality, of course. Similarly, we can draw some conclusions about A minus B also, but that you can see directly from the formula itself. Then the second thing we had seen last time, apart from this triangle inequalities, the next important thing we had seen was the parallelogram law for which gives us the vector sum and difference in the same instance. It gives it together in the same diagram. So let's go over the steps of the parallelogram law. So what we saw is that given any two arbitrary vectors, let's say A and B, and given that we know the angle between them, this angle is theta, we can see that first step was to construct a vector parallelogram. So how do we construct the parallelogram? Draw A and B coming out of the same origin. So this time, instead of drawing them one after the other, we draw them from the common origin. Basically, just pick up that vector A from there and place it on this origin. Similarly, pick up the vector b and place it on the same origin point over here. So that was the first step in this. Then the next step is these are adjacent sides of the parallelogram. Obviously, this angle will be theta over here. Now you can complete the parallelogram by drawing one side from here, which is parallel to A. So let's say that's this side, and another line from here, which is parallel to B. So let's say this one. So second step is done. We have got our vector parallelogram. Now the third step is within this parallelogram, you identify the two diagonals. So you see that there is one diagonal which is going from the common origin to the opposite vertex. And that diagonal, interestingly, actually becomes the resultant sum of A and B. And if you look very closely here, this triangle that is formed over here, this triangle that I am showing with my cursor, this triangle, this is the triangle that was there in the sum wala triangle earlier. So your parallelogram itself now, the diagonal is cutting the parallelogram into this triangle. Half the parallelogram is this triangle. So naturally, this is the resultant. So this is the resultant, and this angle is what we label as alpha. Now there is a second diagonal also, which we will draw like this. We will draw the second diagonal or the secondary diagonal from the head of one vector to the head of the other vector. And we call this one the secondary diagonal. The first one was the primary diagonal. So we can see now by comparison with the other triangle that this is actually A minus B. How you can see this is A minus B and this angle is beta is because now just consider this triangle that you have over here, this one. You can see that it is actually this side is A only, because this side you can take as A. It's the same as the vector below, and this side is minus of B because B was like this. B was pointing in this direction here, so this is minus of B, and therefore this becomes A minus B. And this triangle is present over here. So the sum and difference triangle are both present within the parallelogram. So that is the advantage of the parallelogram now, that within the same diagram, you can show the difference as well as the sum. And it helps us visualize certain types of problems, as we will see further. But other than that, there's no difference because it's the same thing as the two triangle laws, but they are just put together and put into the same figure. The two triangles are superimposed or added one on top of the other, and that gives us the parallelogram diagram. So ultimately, in terms of formula and application, it is no different than the triangle law. So the formula for this diagonal's magnitude, the formula for this diagonal's magnitude, the formula for alpha and beta, they are all the same that we discussed earlier over here. That is these formulas. So these very same formulae, they are applicable here also. There is no difference at all. So these four formulae, they are the same ones which are applicable below there also. Okay. So this is the quick recap of the concepts from the last time, which were the more critical concepts. We discussed a lot of things last time. So triangle inequality, I'm just minimizing it all for you a little bit so that we can get a look at it, and then we'll see how to apply these in some of the questions that I've given. Okay, so in the formula for mod A plus B and mod A minus B, you understand that cos theta का variation कहाँ से कहाँ हो सकता है, -1 से +1 तक हो सकता है. It cannot be greater than +1 no matter what value of theta we take. It cannot be less than -1 no matter what value of theta we take. So accordingly, this quantity cannot become greater than a square plus b square plus 2ab का square, and it cannot be less than a square plus b square minus 2ab का square. So accordingly, you're getting the inequality on magnitude of interest. Now the same concept to apply over here, and you can see we get this relation or the difference of it. And then you also consider the fact that not only it's varying between +1 and -1, the value of cos theta, but also cos theta is negative for which values when theta is obtuse. It is positive for which values when theta is active, and becomes 0 exactly for which value when theta is 90 degrees. So taking that into account, we can also see the comparison of the resultant of A and B with the hypotenuse of A and B, which is root of A square plus B square. The resultant can be greater than a hypotenuse, it can be equal to, it can be less than also, according to what the kind of value of theta is we are dealing with. So those are the inequality equations that we get. And then of course, combining the two triangles, the vector sum and the vector difference, we get the parallelogram principle, where within the same diagram, where you are showing both the vectors drawn from the same common origin, you are getting both the sum, which is the primary diagonal, and the difference, which is the secondary diagonal. and obviously the formula we use in these diagrams, as I told you earlier, is exactly the same. Alright. So this is the application. I mean, this is the recap till now. Now I am turning to worksheet 4, and I will systematically discuss how to apply these concepts in some of the questions. Okay. But before that, there are a couple of corrections in worksheet 4, so I will just inform you about that. Couple of misprints, couple of typing errors. So let me just clarify that first. So in worksheet 4, please incorporate these corrections. Okay, so the first one is this question 1. The correct answer will actually be 150 degrees or C. Many of you have clarified this. It is not A. Many of you asked me on WhatsApp and clarified, and I have given you the reply also. Okay. So just in case you haven't clarified yet, this is okay. And the other correction is in one of the answers. Yeah, question number 6. Okay. The correct answer actually should be that P minus Q vector should become 10 j cap. So what you do is in all options, B, C and D, actually all three, replace 20 with 10. Wherever you see that 20, replace it with 10. So if something is 20 root 3, replace it with 10 root 3 like that. And the correct answer of course will be this one. Whereas at the back it is given as 20 j cap or the option C, which is wrong. Okay. So those are the only two corrections. Okay, now let's come to the questions themselves. Okay. So I think question 1 you should be able to work out yourself. Just draw the diagram of the vector and it will be clear. Or draw the vector in component form. So you can see the vector E, which is minus 10 root 3 I cap plus 10 j cap. So with respect to your standard xy axis, this vector will now look like this. It has a negative x component and a positive y component. So you can see that this vector's x component is like this over here. It's minus 10 root, and the y component is positive like this. So the x component is minus 10 root 3 I cap, the y component is positive of 10 j cap. So the vector itself is this one. It's the one which is coming from the sum of these two. So it will be the hypotenuse over here. Okay, so now you are required to find, so this is the vector E. So now you are required to find this angle. Okay, don't forget that you have to find the angle as the angle with the x-axis, not with the negative x-axis. So you can start by finding out this angle. So you'll see over there very easily that alpha will come out to be 30 degrees. So obviously the theta's proper value will become 150 degrees. Okay, so that's the thing you have to be careful about, that x component is negative and y component is positive. That means it is second quadrant. X is negative, y is positive. This means that the angle theta has to lie in the second quadrant. The moment you see any vector where this is happening, you know that it's just the angle is obtuse. Okay, so that is question 1's solution for you. Okay. Question 2, you just use the formula of A minus B. So in question 2, use this formula that mod of A minus B is equal to root of A square plus B square minus 2AB cos theta. Now in this, substitute A as equal to B as 5 as given in the question, and magnitude of A minus B as 5 root 3. So substitute this in the given question. Okay, so substitute, in the given formula. So substitute this over here, then square both the sides and solve, and you will get cos theta as minus half. So that will tell you that theta is obtuse, and solving further you get theta as 120 degrees. Because cos 60 is half, so cos 120 becomes minus half. Okay. Similarly, question 3, you are given this condition that magnitude of A plus B is equal to magnitude of A minus B. This is given in the question, and now some condition on theta is asked, or condition on A and B. So just put the formula of this over here. Okay. That square root wala formula, and put the formula of this also, and equate the two and solve. And from that you will be able to show that cos theta should be 0. That means theta should be 90. Now when you substitute this with the triangle formula for each one, you will be able to show this. So this is question 3. Okay. Now question 4 is the one I want you people to pay attention to, because now the application of inequality comes in over here. So in question 4 it is given to us that the sum of vectors A, B and C, or the resultant sum of the vectors A, B and C is nothing. It's a null vector. And given that magnitude of A and B, I think are given, right? Yeah, A and B are 20 and 15. Now it is asking that the magnitude of C may be. Now see why it's saying maybe, because theta is not given. Theta is not given. This condition is given, this condition is given, this is given. So it may be which of the following. So the options are now given. So the options is 4, 16, 40 and 50. 4, 16, 40 and 50. Sorry. These options are given. So now how do we interpret this? Okay, because if we don't know theta, we cannot calculate the exact value. But क्या करें, इसमें से क्या हो सकता है? It may be which of the following. So that means what the question is hinting at, saying that मैं theta का value कुछ भी ले लूँ, but there must be some options which are impossible. For any possible value of theta, the option is impossible. That is what the question is hinting, because it's saying maybe इतना हो रहा है. That means I cannot tell exactly कितना है, but I can tell कि इतना नहीं होना चाहिए, or I can definitely rule out that some of the options are not possible. So that means it's coming down to inequality. The moment you see this, you understand it's talking about inequality. So now let's proceed. So what we do in the question here next is, you see that the fact that A plus B plus C's vector sum is 0, is a null vector, that automatically implies that the vector C is negative of the vector which is the sum of A and B. It is negative of the resultant of A and B. Okay. Now that also tells you that the magnitude of the vector C is the magnitude of the the right hand side, which is this, which will actually just become the magnitude of A plus B. Because the moment we are taking mod, the minus sign is not taken into consideration anymore. So this is the case. Okay. And now you also understand that given magnitude of A is 20 and magnitude of B is 15, you know that the mod of A plus B has a certain condition on it. It has a condition that no matter what the value of theta I take, it cannot be greater than A plus B. So it cannot be greater than 35. And no matter what value of theta I take, it cannot be less than the difference of the two. So this is the range of values, because this is your A plus B and this is the difference of A minus B. You can see. So whatever value of theta I take, it has to satisfy this condition. So that means C also has to satisfy this condition, because C's magnitude is equal to the sum of them. So that means C over here also has to satisfy the same condition. It cannot be greater than 35 and it cannot be less than 5. So the moment you have got this condition that no matter what value of theta I take, theta is unknown, but कुछ भी मैं theta लूँगा 40 नहीं हो सकता है, because it has to be less than 35. 50 नहीं हो सकता है, it cannot be greater than 35, and 4 भी नहीं हो सकता है. The only possibility is 60. Okay. So this is where our approach to solving the problem is slightly different. We are making use of inequality rather than solving by substitution in a formula, because one thing is unknown to me, theta is unknown, so I cannot directly substitute in the formula. So then that's why the question is not asking me directly also the magnitude of C. It is just asking it can be this or it cannot be this. So you can see that I don't know whether it's 16 or not, but I know it can be 16. But at the same time, I know that 40 is not possible, 50 is not possible, 4 is not possible. So the only one of the 4 options which is possible for the value of C is becoming 16. Okay, people, so hope this is clear to you. This is a very important type of logic in solving these questions. Okay, so make sure you understand this. Okay, next up, let me come to question number. Question 5, I'll tell you similar hint to make use of similar inequality concept over here. So question 5 में क्या हो रहा है? Magnitude of A and B are given to us. One is 12 and the other is 16. Oh sorry, it's P and Q. It doesn't matter. So magnitude of the vector P is 12. Magnitude of the vector Q is 16. And it says that the resultant and the angle is obtuse and theta is obtuse. So make use of that mod of P plus Q will be less than root of P square plus Q square. So we know that theta is obtuse. It's greater than 90. But at the same time, it cannot be less than P minus Q also. It cannot be less than this. So given this, I can see that given these values, I can see that magnitude of P plus Q is case mein, it cannot be equal to it. Always has to be less than 20. But at the same time, it cannot be less than 4 also. So it has to be something between 4 and 20. Not equal to 20, but it can be equal to 4. So it can be 4 and greater than that, but at the same time it has to be less than 20. So now you select which option is correct and you will get the answer. This is another example of inequality solving. Okay, so hope this is clear. So this here using the obtuse angle concept. We are using the obtuse angle concept. Then theta is obtuse, cos theta is negative. That's okay. So if some of these things didn't strike you while you were doing it, it doesn't matter. You have to get used to this different type of solving method. You are as yet just used to substituting in the formula or drawing a diagram or something. But here it is like an inequality kind of logic in mathematics. So you'll get used to it. As you solve enough questions, you'll get used to it. Now let's come to question 6, for which I'm just going to give you a hint. For question 6, what you do is write the vectors P and Q in I cap J cap notation. You do this, okay, and then you will find out how much P minus Q. It will be very easy. So do this and then next step. From the given diagram, just write P and Q in component notation, in I cap J cap notation, and you will get very easy. So that's that. Okay, now let's come to 7th question. 7th is again a bit of application of triangle law kind of thing. It is given that P and Q are two vectors such that the angle theta between them is 150 degrees. And it is also given that, what else is given, just a second. And the resultant is perpendicular to P. Okay, and the resultant of these two vectors, P plus Q, is such that this resultant is perpendicular to P. So from this we have to find these two. So we can use a number of different methods here. For example, we can just go with the formula based method. We can go with the formula based method like this, that if this is P and this is Q and this is the resultant of P and Q, this angle, if we denote this as alpha, this angle, if we denote this as theta. Now, given what all is there, given that theta is 150 degrees, and given that alpha is 90 degrees, and what we have to find the ratio of P by Q. So you can just say we have to find the division of P by Q. So what is the formula we can use? If we are going by the formula based method, we just use this formula that tan alpha is equal to P sin theta, sorry, Q sin theta, my mistake, upon P plus Q cos theta. Now this tan alpha should become tan 90. That should become Q sin theta, so sin 150. That also helps. Upon P plus Q cos 1. Now you know that tan 90 is what kind of quantity? It is undefined. So that must be equal to some quantity where some numerator divided by some denominator, but that denominator must be equal to 0. That is the condition for the undefined nature of tan. So whenever we equate tan 90 with something on the other side of the equation, the denominator should become 0. So we can use that. So using that concept, the denominator here is P plus Q cos 150. So now you know that cos 150 is minus cos 30. So that is minus root 3 by 2. So P minus root 3 by 2 Q is 0. So your answer should become P is to Q is equal to root 3 is to. So this is, you can say, the most, brute force kind of method. I don't want to really use any tricks or anything. I'm just making use of the formula that I already know. I know the formula for tan alpha. उसमें alpha पता है, theta पता है और P is to Q का ratio निकालना है. Okay, so I'll just leave this on the board for a little bit of time so you can understand the whole process. Okay. Now in the same question, I can just use a different concept. I mean, I can just go with geometry now. Why I have to do so much work with formula and all? Just put this condition over here. In this triangle only, make it so that alpha is equal to 90 degrees and theta is equal to 150 degrees. So apply that condition. The triangle gets a bit modified. It now looks like this. You draw proper triangle with that condition, it will now become like this. Look something like this now. When this alpha is 90 degrees, this is the resultant. And for the other two, you see the angle between P and Q, this one is 150 degrees, that's your theta. This is Q. This is P. So you know this angle is 30 degrees. So once you know this right angle triangle is there, why to do all this time? Why to apply so much formula and all that? You don't need to do anything. Now just use trigonometry for the right angle triangle. That base upon hypotenuse is equal to cos of the angle. That's it. So now that will directly give you the answer that this one is. So much more direct approach. It should directly give you this. Especially at the exam level, you want to be time efficient while solving questions. So you realize that the moment it was given to you in the question that the resultant is making 90 degrees with P, you know you're dealing with a right angle triangle. So the first thing you should do is you should see that if you can get away with just using the property of right angle triangle, like sine, cos, tan, or Pythagoras theorem, or whatever is required in the given question. Alright, so these are the two ways of solving this question. Number 7. Right, now next let's come to question number 8. Fairly simple. I'll just tell you what to do in it in case you haven't got the answer. So in question 8, what is given in the question is that magnitude of E is equal to magnitude of B, and the ratio of E plus B is to the magnitude of E minus B. That ratio is equal to 1:2. So from this we have to find theta, the angle between A and B. It's a very simple case of substitution. So you just apply this condition now, that magnitude of A plus B upon magnitude of E minus B is equal to 1 by root. Then another step you can do next is you can just square both the sides. It will make life even easier. So this will become E square plus B square plus 2AB cos theta, right, upon E square plus B square minus 2AB cos theta is 1 by 3. Now in this, remember that magnitude of E is equal to magnitude of B. That was given. So let's take that as x. So you'll see x will cancel out. So you'll get x square into 2 plus 2 cos theta. Even that 2 will cancel out actually. X square 2 minus 2 cos theta is equal to 1 by 3. So taking 2 common and cancelling that also. That 1 plus cos theta upon 1 minus cos theta is 1 by 3. Or from this you will get cos theta is minus half. That means theta is obtuse. And since cos 60 degrees is half, so you know that cos of 120 degrees minus half, that means theta comes out to be 1. So nothing much to do. Very simple direct substitution type of question. Alright, so moving on to question 9 now. So 9 again you do this. Write E and B in component form first. Do that. The next step, find plus b. How much that comes out to be? And then apply the condition that e plus b is along the y-axis. So applying that condition, you will get your answer. You will get the magnitude of A. When you apply the first step, actually, you see that because A is a vector of some unknown magnitude, but making an angle of 60 degrees with the x-axis, you can write it as A cos 60 I cap plus A sin 60 j cap. And B is directly shown as magnitude 10 but direction along negative x-axis. So this is that. So once you got this, now you next step is find out A plus B. How much that is, add these two, and then apply the condition that it is along y-axis. So you get the condition on E required. So that is the way of solving this question. Okay. Then this a simple question. Use triangle inequality similar to how you done in one of the questions earlier. I tell you which one. Similar to how we applied triangle inequality in question 4. Okay, so just refer to that question 4 and see how you use triangle inequality, you'll get the answer. Now let's come to the more than one option correct type of questions. So let's start with question 11. So it says that magnitude of A is equal to magnitude of B equal to 10 units, and the angle between them is 120 degrees. Now we have to find out various things. We have to find out which options are correct. So for example, we have to find out about E plus B. Find out about E minus B. Okay. So we can just use the formula. Mod of E plus B is equal to root of E square plus B square plus 2AB cos theta. So when you do that, when you substitute these values, you will see that this comes out to be 10. And similarly, the angle that A plus B makes with the vector E, tan alpha is B sin theta upon A plus B cos theta. So when you apply this again over here, the value of theta being 120 and all that, so remember that sin 120 will be half. Sorry, will be root 3 by 2. Sin is positive in the second quadrant, so it will be sin 60, which is root 3 by 2. Whereas cos 120 will become a negative quantity, and that is minus half. So use these values both in this formula as well as in this formula, and of course put A and B as 10 each. You get this, okay? So this will come out to be actually 1 by root 3 on this one. So you'll see that alpha is 30 degrees. Okay. Similarly, you find out by same method, A minus B, you apply the formula. Okay. So from the formula, we calculate how much it is. And tan beta is similarly B sin theta upon A minus B cos theta. So apply all this here also. So you will get beta as 60 degrees and you will get mod of A minus B as 10 degrees. Okay. So this was more or less about the direct application of the triangle law formulae for both sum and difference in the same question. Okay, now question 12 is an application of this direct concept. Apply the inequality that mod of a plus b is greater than root of a square plus b square if theta is acute. Just apply this concept and you will get the logic. And vice versa. Mod of a plus b is less than root of a square plus b. But you'll have to consider both these things. If theta is okay. Now comes the tricky question, the question number 13. So 13 I'm going to make you solve right now only with me. So question 13 ऐसा है that what we have got in the question is that just a minute, there's a bit of lag, so I'm going to reshare once. Okay. Just give me a moment. Probably my internet slowed down a little for some reason. It should be okay now. Right. So question number 13 is like this, that we have a regular hexagon ABCDEF of side length, I think it is 20 centimeters if I'm not mistaken. I'll just check it. Now we have to find various options. Options involve operations like this: EB plus BC plus CD plus DE. This thing. We have to have some information about this. Then EB plus BC plus CD. Information about this as a vector. And then also EB, I think plus BC minus CD. These all kind of things we have to do. Okay. So what we'll do here is we will solve everything by component method. So we will use component notation. So how we do that is we'll use the more convenient way of representing the hexagon. That is a hexagon which has the base, one side parallel to the x-axis. Let us make life easier for us. We are analyzing this. Let's say, roughly speaking, this is a regular hexagon. And I have drawn it such that the base is parallel to my x-axis. I have taken my coordinate frame such that so that it's easiest to convert everything in component. I know that the edge length is 20 centimeters. So if I label this side as AB, this side as BC, this side as CD, DE and EM, then I can think of this as a vector now, away to B as a vector E. Then I can think of this as a vector, this vector from B to C, like that. This this as the vector C, and this as the vector B. Now what I want you to do is, you want to write the vectors in the I cap J cap notation. So I'm going to help you by writing two of them, and the other two you have to write. So I'm showing you that AB here will come out to be 20 I cap, but BC, I'm writing it directly, I'll justify also, but I want you to work on it yourself also. BC will become 10 I cap plus 10 root 3 j. The first thing is you verify for me and tell me is this correct, and then similarly calculate how much, how we write CD, the next vector, and how we write DE, the next vector. Once you've done this, the rest of the question will become easy. So just do this as a class exercise right now. I want you to, first of all, I want you to verify this is correct or understand why this is to be like this. And then I want you to find out these two. Then we'll come back to the option. So just think about this carefully, people. I'm sure many of you are aware of these special properties of a hexagon. Make use of that, a regular hexagon. The regular hexagon has some very nice symmetry properties. Hint to you is if you join all the corners A, B, C, D and all with these centroid of the hexagon, you get a very nice shape. Use that as a hint to try and understand this. Okay, people. So hope you have got this till date. This thing. Let me write down the values. Then I'll come to the logic also. So hope you found CD and all. So I'll put up the values first. You compare and see. You should be getting this as minus 10 I cap plus 10 root 3 j cap, and you should be getting this one as minus 20. So first see, are you getting these values or not? Then I'll explain how I came to this conclusion. Yeah, and I have seen your message of question 6 explaining again. I'll come back in the end to that. Okay, so let me explain how I've come to this conclusion. I've come to this conclusion by using a very simple property of a hexagon, of a regular hexagon, that is that if you join the vertices of a regular hexagon by what we can think of like diagonals within the shape of the hexagon, you come to something very interesting, that each of these is an equilateral triangle. So if this side length is L, okay, first of all what happens is all these angles, because the side lengths are all equal, all the sides are equal, so that's why these angles are all equal. This angle is equal to this angle is equal to this, like this. So you're dividing 360 into 6 equal thetas. So that angle theta becomes 60 degrees. First. Now once you can see that the angles become 60 degrees, now if you see any of these triangles, A, B, C, D, E, F, and let me name the centroid as O. So for example, if I just pick out this triangle, okay, EBO. Now I know that this angle theta is 60 degrees. That I got. Okay. I also know that within this triangle now what is happening? So the symmetry, this side is equal to this side. That means this angle is equal to this angle. So this angle is alpha, this angle is also alpha. So you can see 2 alpha is equal to 180 minus theta. So from that you can see that alpha is also 60 degrees. So that is what is showing that each of these triangles is equilateral. Therefore, all 6 triangles, ABO, BCO, like that, these are all equilateral triangles. So that's the first thing. Now the other thing is that because these are equilateral triangles, okay, now let me redraw this. Okay. So don't worry about the crooked shape. It's just for demonstration. So it's not a perfect diagram, but anyway. More or less something like this. Okay. We'll correct that later. Now क्या हो रहा है? ये angle 60 है, ये angle 60 है, ये angle 60 है. In the next angle, this angle is also 60. So what happens? This exterior angle, this is also 60. So now same thing over here also. This exterior angle also becomes 60 because these two are 60. Okay. And then same thing over here. This also becomes 60. So not only is it important that they are all equilateral triangles, it's also important to understand that the interior angles as well as the exterior angles, they all become 60 in this way. So I'll show how that will become significant over there. So that is why now you can see that if I had taken this as AB and this was along my x-axis. Okay. Now you see the vector BC. Is this vector? It's brought over here. So this vector is at an angle 60 degrees with respect to the x-axis. This is the vector BC. So that is why BC vector was 20 cos 60 degrees I cap plus 20 sin 60 degrees. That's how it became 10 I cap plus 10 multiplied by root 3. So that was the case of BC. Now you look at this one, CD. So look at that separately. So pick up that vector CD from there and bring it here. So the vector CD is looking how? It is looking like how much angle it is making with the x-axis. Now you see, this is your x-axis. E angle. Now in this was already 60. This was already 60 here. You can see this and this. So this total angle is how much? 120. Okay. So your CD vector is, so now according to your CD vector becomes 20 cos 120 degrees I cap plus 20 sin 120 degrees. And as you know, cos 120 is minus half, so this will become minus 10 I cap. Sin 120 is plus sin 60, so that's plus root 3 by 2, so 10 root 3. So that is your justification for this. And then finally you can see that your vector DE, that should exactly be anti-parallel to this one. Why? Because पहले ये 60 से घूमा, then 60 plus 60 120, then 60 plus 60 plus 60, so that's 180. So they should be exactly 180 degrees or opposite to it. So you can see that's why. So that is the reason why this is working out this way. Okay. So now you got this. So you already got the vectors AB was 20 I cap. You got BC, CD and DE as minus 20 I cap. Now you work out the options and you will get answers. So now just substitute this in each of the options and you will get whatever is required. Okay people, so hope this is clear. Right, so now let us move on to question 14 and 15. You still have to complete the options in this, but I think this will be enough for you to work out without any difficulty. The options. Okay. So come to question 14 next. Go through it and explain. So question 14 may what is happening is 3 different displacements are given to you. Okay. P is a displacement of 10 meters towards east. Q similarly is a displacement of 20 meters towards 60 degrees north of west. And finally, R is a displacement of 30 meters, but it is in which direction? 60 degrees, 30 meters, at 60 degrees south of west. Okay. So the main thing is, again, what we have to do is convert to components. Convert this to I cap, J cap notation. And I'll help you out with the diagram and you do this yourself from there. Okay. So if I take my system such that y-axis is pointing towards north, next axis is pointing towards east. So this is west, this is south. Now in this diagram, let us understand where each of my vectors above will be placed. One is 10 meters towards east, the other is 20 meters, like that. Okay? So 10 meters towards east is very simple. This will look like this. This is where my vector A is placed. So this is my vector A, which is 10 meters towards east. But now more complicated. Where is my vector B? Sorry, that was vector P. Where is my vector Q? It is 20 meters at 60 degrees north of west. Okay, so let's understand what this direction is. 60 degrees north of west. Kaun sa direction hoga? It will be a direction somewhere like this. Okay. So my vector Q now will have to be in this sort of a direction, north of west. Aisa hoga. So this should be my vector Q. Magnitude is 20 meters. But more importantly, its direction is this angle is 60. This is what we mean by 60 degrees north of west. That means west से आप north की तरफ turn कर रहे हैं कितने से 60 degrees से. So this is my vector P. Okay. And just a small correction, this was the vector P. Okay. Now like this, what I want you to do is yourself, before I put it up on the board, similarly draw the vector Q. Okay, I'm putting up what the vector Q is. Just try and draw it yourself. Sorry, R. The vector R is 30 meters, my mistake. 30 meters, but in which direction? South of west. So try and draw it yourself. So 30 meters at 60 degrees south of west. So draw that vector in the same diagram. Try it yourself and then I'll put it on the board. So you will see that the vector R should be somewhere here. South of west should be like this, and it should be a little bit longer because it's 30 in magnitude. So just in the interest of accuracy, it should look like this, 30 meters in length. But more importantly, this angle will be 60 degrees. Okay. Now the next step, so you've drawn the diagram. That's done. Okay. Now I want you to convert all this into component form. So convert to components. So the vector P will obviously be written as 10 I cap. But what is not so obvious and what you will work out yourself is that when you see vector Q, it will be minus 10 I cap plus 10 root 3 j cap. Okay. So just verify this. Is this correct or not? Yourself. Okay. And similarly, the vector C will become minus 15 I cap minus 15 root 3 j cap. So again, when you are revising this, verify this that this should be correct. And from this now, solve the options. So finally, from this, solve the options. Whatever operations are asked in the operation in each of these options, work them out and check out whether the option given is correct or not. So this is the method of doing question number 14. So just take a look at this carefully, and we come to question 15 and complete this. I've just written down the I cap J cap notation. You have to actually work it out and see why Q and R are coming like this. So its last one is R. Alright, so that's this one. Now let's quickly go through question 15. So question 15 says that the vector E is, I think, I cap plus root 3 j cap, right? Yes. So I cap plus of root 3 j cap, and the vector B is some xi cap plus yj cap, such that the magnitude of B is equal to, what is it, 4, I think, 4, and B is perpendicular to E. Okay. Then how much can x and y be? Okay. So we can do this question in two ways. One is we can fit option, check if it is correct or not, or the other is we can directly try and draw the vector B and come up with a formula for it. So actually the second method is easy. We directly try to draw the vector B. That will be very easy to understand, because you can see the vector E is such that magnitude of A will come out to be root of 1 square plus root 3 ka whole square, so that is 2, and tan theta will come out to be root 3 by 1 dy by x, so that is theta will come out to be 60 degrees. So the vector E in my diagram here should be looking something like this. It should be a vector of magnitude 2, which is an angle of 60 degrees with the x-axis. Magnitude is 2. So comparatively, how can we construct the vector B according to this information which is given? We can draw the vector B like this. Where the magnitude of vector B is 4 and this angle is 90. So now when I want to write vector B component form, so for B, you can see that its magnitude is 4, but what about its angle with the x-axis? Theta with the x-axis is 60 plus 90. Because it is already making 60, so the theta with the x-axis is 60 plus 90 or 150 degrees. So recall that cos 150 is minus cos 30, so that is minus root 3 by 2, and sine 150 is positive of sine 30, so that is half. So using these values, you can see that the vector b will become b cos theta I cap plus b sin theta j cap. So it becomes 4 into minus root 3 by 2, so that is minus 2 root 3 I cap plus 2 j cap. So you can see that according to this, x's value should be minus 2 root 3 and the corresponding value of y should be 2. Okay. So first make sure you understand this process. Now also listen to what I am saying very carefully. I am saying this is not the only possible b. There is another vector which satisfies the same condition that the vector b is satisfying here. That it is perpendicular to a and its magnitude is 4. There is another vector which can potentially become the vector b. This set of values that x is minus 2 root 3 and y is 2 is satisfying the condition. But what I'm saying is that's not the only vector. So try to understand that from the diagram. So if you pay attention closely to the situation here, you realize that the other vector that satisfies this condition is this one. We could have also drawn a vector which was like this. Also drawn a vector which was like this. This also could have been b, where this angle is 90. So this vector is, let's say, b prime. Now that b prime is also satisfying the same thing as long as the magnitude is 4. But once we've got b, this b prime is very easy to understand because this is just opposite. It's having the same magnitude, but it's opposite. It's at 180 degrees. So we can see that the vector b prime is nothing but minus of the vector b. So since we have found the vector b, you can see that b prime is the vector 2 root 3 I cap minus 2 j cap. So vector with a very similar orientation as the vector b, but is lying in the 4th quadrant, whereas b was lying in the 2nd quadrant. So this is another set of values which is possible. That we could have taken the value of x as plus 2 root 3 instead of minus 2 root 3, but then the corresponding value of y would have to become minus 2. So this has become another solution set. So we'll say over here that there are 2 solution sets for the given question. Okay. One is corresponding to the vector b and the other is corresponding to the vector b prime. So that is why more than one option is correct over here. Okay, people, so hope this is clear. So that completes the worksheet discussion. So just finish off everything, make sure you get the answers, understand all the solutions properly yourself, and do all the questions on pen and paper. Okay? Just because you have understood maybe the solution over here or the method of solving over here, don't compromise on your own pen work, because that is the only thing that you learn 100% from. Solving questions will come with 100% efficiency when you actually do them on pen and paper yourself. So do the questions and sort of make sort of fair notebook where you have the solutions written in good amount of detail. That will help you in your learning as well as it will help you for future revision. And any point of time, any confusion that comes up with the questions, you can send me a message individually. I'll help you out with that. So you don't have to wait till the next lecture or anything for that. All right, now let's come to the next section, which is today's part of vectors, where we'll understand components in 3 dimensions. In 3-dimensional system. In short, we call this 3D. So the system that I'm referring to is a 3-dimensional Cartesian, or what we also call a rectangular coordinate frame. So now the best way to visualize a 3-dimensional coordinate frame is just visualize the room in which you're sitting. It's roughly a rectangular kind of cuboidal rectangular kind of shape. So visualize any one corner of the room as your origin. Okay? So let's say one of the corners. So when you look ahead in front of you, you see a wall. The room in which you're sitting, if it's a 3-dimensional room like this, now you're sitting like this, let's say facing this wall. So think of this as your origin. So this point is your origin. And now the floor and the front wall have a certain interface. Okay, so that becomes, let's say, your x-axis. So think of that one as your x-axis. Then this one over here, the wall and the 2 walls together, they are making an interface. So that is, let's say, your y-axis. So your x-axis. So don't think of this like a 2-dimensional diagram. This is a 3-dimensional diagram where this is your origin. Okay. So you can actually even think of it like this. In the diagram I've shown on the side, instead of this point, take this point as your origin. Okay. So this is your x-axis and this is your y-axis. Then correspondingly, this one, this edge, this will become your z-axis. So in this diagram, your z-axis will show up over here. Just look into the wall in front of you and you'll understand. If this is the corner which is to your front left side, okay, so you're facing a particular wall. So on that wall, the corner which is on your front left side, okay, that one is the origin. Okay. Then the horizontal edge of the floor, that becomes your x-axis. The vertical edge of the 2 walls becomes your y-axis. And to your side, there's another wall. So that wall and the floor are having an edge. That edge is your z-axis. Okay. So in this, you can see that the floor is this is this floor of the room, this one, in which you're sitting. The wall that is directly in front of you, that is this one. That is the XY plane. So this wall and the floor are actually perpendicular to each other. That is why this angle is 90. Okay. So this one is this plane. And you're sitting over here. This is the wall in front of you. This is the floor. This is the origin. To the side of you, that is again perpendicular to the floor, and that is your exit plane. That's why this angle is 90 and this angle is 90. So this is our three-dimensional coordinate frame. Okay. So as you can see in the diagram, the three axes are mutually perpendicular. Okay. X, Y, and Z are what we call mutually perpendicular axes. What that means is that X is perpendicular to Y, X is perpendicular to Z also, and Z is perpendicular to Y. So any pair of axes is mutually perpendicular. So hopefully, with this perspective diagram, you're understanding that this is not a two-dimensional diagram. This is a three-dimensional diagram. The red colored surface which I've drawn is actually the floor of the room in which you are sitting. Okay. The blue colored surface is one of the walls, the one in front of you, and the green colored surface is the other wall which is to the side of you. So all these three surfaces are perpendicular to each other, and therefore the axes are the edges which are perpendicular to. So these two, the X and the Y, X and the Z axis, are the two edges on the floor from the corner point of the room, which is on the floor, and the vertical axis Y is nothing but the vertical edge between the two walls which are perpendicular to each other. The wall in front of you, the blue colored wall, and the wall beside you, which is the green colored wall. Okay. So this is how we draw a three-dimensional rectangular frame. Okay. So I'll tell you another way to visualize this also, but first make sure you understand this and try to make a note of this. So whenever we are describing a vector in a three-dimensional system, it will be described in reference to a Cartesian coordinate frame or a three-dimensional rectangular coordinate frame. So such a coordinate frame will have three axes, X, Y, and Z, which are mutually perpendicular, and the planes that are formed by the system of three axes, those planes will also be perpendicular to each other. So the XY plane and the YZ plane and the XZ plane, they are mutually perpendicular planes. Okay. Now, of course, in this system, you also have the negative axis that I have not drawn so that the diagram doesn't get cluttered. Okay. But actually, you have the negative axis also. So when you visualize this, the complete thing with the negative side also. This is your X and Y axis. This is your Z axis. So you also have the negative Z axis. Z prime is on that side. Also have the negative X axis. X prime is on this side. And you also have the negative Y axis. So Y prime is on this side. X. So now the next thing we'll do is in this system, we'll define the, before that, let's see another way to understand this system. Another approach. So for this approach now, what we do is first to consider a cuboidal box or a cuboidal frame. Let's say you use matchsticks. To form. So this is a rectangular cuboid. So all planes or surfaces are mutually perpendicular. Now you take any one corner of this as your origin, and now you'll see that each of the edges will become the axis. Okay, people. Now, unfortunately, I'm having network issue, so we'll just take a quick 2-minute break while I refresh the network. Okay? So I will just have to I'll just have to refresh my network, guys. So just take a 2-minute break and I'll be back. Okay, so people, hopefully network issue is resolved. I trust all of you are getting the audio video properly now. Okay. So coming back to another way to visualize my three-dimensional system. It's something like this. Yeah, so I have a rectangular cuboid such that all the planes are mutually perpendicular. Now what I do next is I take any one of the corners as my origin, any corner point as the origin. So by default I've taken it this one. So this again, visualize this as the skeleton of the room in which you are sitting. This is the structure of the room in which you are sitting. So if you take this axis now as your x-axis, okay, people just hang on. Unfortunately, another network issue is happening. So just wait for a minute or so. Okay, so just hang on. All right, so starting in a new system now. So I'll just redraw and take you through that concept again. So what we are seeing is that the three-dimensional coordinate frame can be understood in a different manner also by constructing a rectangular frame, a rectangular cuboidal frame. So we have roughly this is representing rectangular cuboidal box end with all surfaces perpendicular, mutually perpendicular. Now you can take any corner point of it, like this corner point as the origin, and you can take three of the mutually perpendicular edges as your axis. So if you define this as your x-axis, this axis as your x-axis, then correspondingly you define, let's say, this axis as your y-axis. That particular edge becomes your y-axis. And correspondingly then, this third edge, which is perpendicular to both of these, that will become our z-axis. So you can see that they are all mutually perpendicular. X is perpendicular to y, y is perpendicular to z, and z is perpendicular to x. And also that there is a continuation of the axis on the other side, which is the negative axis. This x-axis continued on that side, that is your negative x-axis, x prime. Similarly, the z-axis continued behind like this. This is your z prime. And similarly, the y-axis continued below. This is your y. So that's another way of visualizing in 3 dimensions, the 3-dimensional coordinate frame. So just give you perspective. So now for 3-dimensional vectors, so components in 3 dimensions for this purpose, once we have the first thing, which is the 3-dimensional coordinate frame or the coordinate axis, the next thing that becomes important for us is the base vectors, how we define the unit vectors or the base unit vectors. What we also call the standard unit vectors. So they become over here, I cap and j cap as usual, we had before also. But now we have an additional one which is called k cap. So I cap and j cap will have the same definition, but k cap will be the unit vector along the positive z-axis. Because I cap was the unit vector along the positive x-axis, and j cap was the unit vector along the positive y-axis. So in addition to I cap and j cap, now we have the third one, which is k cap. So that's the context with respect to this diagram. So in this diagram, for example, j cap will be pointing like this along the y-axis. I cap will be pointing like this along the x-axis, and k cap will be pointing like this along the positive z-axis. So we can define any vector now which is lying in any sort of arbitrary direction. The vector does not have to lie in the xy plane or the yz plane or the zx plane. It can be outside of all the 3 planes. So basically any vector which is lying in any sort of orientation within that box, we can represent it in form of I cap, j cap and k cap. So that is our 3-dimensional vector system. So hope this is clear to all of you. So you define the 3-dimensional coordinate frame, then you define the base vectors or the standard unit vectors, and now you come in a position where we can define the vector in component form. So vector in in component notation or component form, three-dimensional component will be given by an equation like this. We will just have an additional component which is along the z-axis. This becomes the formula of the vector or the representation of the vector in three-dimensional coordinate frame or in three-dimensional component form, where you know by definition Ax is the x component of the vector. Similarly, Ay is the y component of the vector A. And now, analogous to that, Ez has become the z component, where we understand that Ax, Ay, and Ez are actually scalars, but with sign, with positive or negative sign. Just like in two-dimensional system, you had the two components Ax and Ay. Like that in three-dimensional system, now we have three components Ax, Ay, and Ez. So next, with examples, we'll understand how to visualize a vector in 3D when we know the three components and how they do. So I'm just taking you through the whole process once more. So when we are defining components in three dimensions, the first thing is we need to have a three-dimensional coordinate plane. So how do we visualize a three-dimensional coordinate plane? It's mutually perpendicular axis. They are mutually perpendicular x, y, and z axis. The best way to visualize them is just think of a cuboidal box, a rectangular cuboidal box, where all the six surfaces, they are such that any two adjacent surfaces are perpendicular to each other. Then visualize any corner of that box as your origin and take two of the perpendicular axes as x and y. So the third one, which is mutually perpendicular to both of them, that automatically becomes the z-axis. So this is how we understand the x, y, z. Once you understood the x, y, z system as mutually perpendicular axis, then next is you define your base vectors or your standard unit vectors. So in addition to I cap and j cap we had before, now we also had k cap, which is along the z-axis. So with the base vectors in place now, we can represent any vector in three-dimensional form as x component into I cap plus y component into j cap plus z component into k cap, where remember the components individually are scalar quantities, but when you multiply the component with I cap, it becomes a vector. So this Ax I cap is actually a vector along the x-axis. Ay j cap is actually a vector along the y-axis, and Ez k cap is actually a vector along the z-axis. The voice is not coming clear, is it? Wait, I'll just check. So Shan, but I'm checking at my end. The monitoring seems to be fine. So maybe there's also connectivity issue at your end also happening. So if that is the case, then don't worry. The recording has the audio in the correct issue. So you will be able to reference it later. There won't be any problem in the recording. Okay, thanks, Shan. All right, so coming back here, now let us try to visualize. Okay, let's try to visualize this. So let's take an example to understand. So suppose we have an example where vector E is, let's say, 12 I cap plus 4 j cap plus 3 k cap. Now let us try and find out the magnitude of the vector E, okay, and try and draw vector E. So it's very difficult because we are drawing in two-dimensional plane, whereas the vector itself is three-dimensional. So let's try to visualize. Okay, so let's come back to our coordinate frame system. Yeah, so if this is my x, y, and z axis, so now you have to think in terms of 3D. You have to understand that this is actually perpendicular to 3D. So here this angle is also 90, here this angle is also 90, this angle is also 90. Okay. So now let us start by drawing the vector 12 y cap. How does that vector look? Just forget about the other two components. Just think how 12 y cap looks. So 12 y cap will be a vector like this. It will be, let's say, a vector which is joining the origin of my system with a point over here, which is, let's say, the point E, which has coordinates 12, 0, 0. Such a vector. So I can think of this vector as the vector OE. Now, similarly, now let us visualize in this system how the vector 4j cap looks like. So 4j cap will be similarly a vector which is joining these 2 points. From the origin, if I draw 4j cap, it should be a vector that looks like this. It should be perfectly along the y-axis. And if its magnitude is 4, that means suppose this end point of the vector is B. The coordinates of that point are what? They are 0, 4, 6. You can also think of this as the vector OB. And you can see that OA is perpendicular to OB. They are mutually perpendicular. Now, similarly, let us look at the third one, which was 3k cap. So that in this diagram would look like a vector. 3 units along the positive z-axis. Let's say that is a point over here, which is 0, 0, 3, lying on the z-axis. So that is the vector OC. And you can see that OA is perpendicular to OB. OB is perpendicular to OC. And OA is also perpendicular to OC. So these are 3 mutually perpendicular vectors. So now I have understood these 3 vectors individually. Now what is my vector A? My vector A in all of this was the sum of these 3. So let's understand how the sum of these 3 is. I have understood how individually 12 I cap is looking. I have understood individually how 4 J cap is looking. I have individually understood how 3 K cap is looking. But how does the sum of these look? So let's understand that. So for that, let us actually draw that rectangular box kind of. And let's imagine that if I were to compare this box with the previous diagram, then this point was the origin of my coordinate system. This point was E, which I labeled as 12, 0, 0. This corner here was B, which I labeled as 0, 4, 0. And this corner here was C, which I labeled as 0, 0, 3. And therefore, this thing continued here is my z-axis. This only is my z-axis. this thing continued here, my x-axis, and this thing continued here, my y-axis. So this is how it's looking. Now remember what I have to do. I have to find out this thing. I have to find out the vector E, which is 12 I cap plus 4 j cap plus 3 j cap. Let's see how I'll do that. So if I make a displacement starting from the origin of 12 I cap, where I will reach this point E. So this would be 12 I cap. Then from here E, I have to make that displacement OB, but it's not from B, it is from A. So my displacement OB, how will that look now? My displacement OB in this diagram will become this one, or my displacement of 4 j cap in this diagram now will become here. So actually from here I will reach this point. When I make this displacement of 4 j cap, and I would have reached another corner of the same diagram, and this corner is, let's say, D, and this would have coordinates 12, 4, 0. You can see the point D is lying on the xy plane. Its z coordinate is 0, but its x component is 12 and its y component is 4. And then I'm not stopping there, I'm making another displacement of 3 k cap. So that means I would reach this point over here. Here I would reach this point. So 12 k cap, which I had earlier shown as OC, but that kind of displacement I have to make not from O, I have to make it from the point D. So I'm coming out in this direction and I'm reaching here, this point. So this is my 3 k cap, let's say. So this point here is becoming yet another vertex of mine, which is now having the coordinates x12, y4, and z3. So now what is the vector A in all of this? It is the sum of these 3 vectors. So where have I ended up after completing the sum of these 3? I started from the origin, made a displacement to A, that is my 12 I cap, then reached the point B, that is my 4 j cap, and then reached the point E from here, that is my 3 j cap. So my final position is which? It's this point E, and my initial point was what? It was O. So my vector, which is A, in this diagram, where will that vector be lying? That vector will be lying over here. This vector will become my vector. Okay. So this is how we can visualize this. I'll come to the magnitude of A now also, but now you can see you're getting some geometrical meaning of it. Okay. Starting from that corner O, after 12 I cap ka displacement here, that means you went to across this edge, which is 12 meters long. Then you made a displacement of 4 j cap. So you went along the perpendicular edge and reached this corner, which is now having coordinates 12, 4, 0 compared. Then you made a displacement along the z axis. So that would be along the other edge, which is perpendicular to the first two. So that is 3 k cap over here. And finally you reach which corner? You reach that vertex, which is diametrically opposite to 2. So you can see in this diagram what is happening. My 12 I cap was actually equal to the vector OE. Then my 4 j cap was actually the vector from A to D, that edge, AD. And my final vector 3 k cap was this edge, which is BE. So that means what is my vector A itself, which is the sum of all these 3? My vector is becoming from O to the point E. So in language of geometry, the vector A is nothing but what we call the body diagonal of the cuboid. So you can see that the vector A is the body diagonal. So a cuboid is 3-dimensional. So it has 2 types of diagonals. One is the face diagonal. That is a diagonal across each of the 6 faces. They are called the face diagonals. But there are also 4 such diagonals which are body diagonals. Okay? From the origin, you can see that there is one body diagonal. Similarly, from this point, there's another body diagonal. Similarly, from this point, there's another body diagonal. So there are 4 body diagonals in all like this. So in this case, it is that body diagonal OE. It's the vector which is along that path O to E. So hence, geometrically speaking, it becomes nothing but a body diagonal. Okay. So hope you've understood this 3-dimensional picture. So that is how you visualize a vector when all 3 components are given. If the components are x I cap, y j cap, and z k cap, you just think of making a cuboid whose edges, whose perpendicular edges are x, y, and z. And ऐसे cuboid का जो body diagonal है, वो क्या हो जाएगा? वो मेरा vector x I cap plus y j cap plus z k cap. Okay, so first of all, just try to make sure that this is clear to all of you. This is a little bit, tricky in the beginning because you are trying to visualize a diagram in 3 dimensions using a 2-dimensional tool. The pen and paper you have or the whiteboard that I have, it's not a 3-dimensional tool, it's a 2-dimensional tool. But you have to visualize this in 3-dimensional space. So think of that box I have drawn, like the room that you're sitting in. So one of the edges is 12 meters long, let's say, the other edge is 4 meters high, and the other edge is, let's say, 3 meters wide on that side. So as you go from one corner of the room to the diametrically opposite corner, that thing, this one corner in front of you to, let's say, in your front to your left hand side, to the corner behind you up there on the right hand side. That corner to corner is becoming the vector. That is becoming the body diagonal of the room in which you are sitting. So that is the 3-dimensional vector. Okay. So hope this is clear. Now let us come to how we'll find magnitude of. Now we want to find out from this thing given. Just a moment. Okay, so let us see how we will get the magnitude of the vector form. Okay, so it is like in that diagram, OA had a side of 12, then AD was of side 4, and DE was the side 3 meters. And now we wanted to find out OE. We wanted to find out this because this is basically our magnitude of the vector. Going back, okay. So what we'll do is we'll apply Pythagoras theorem twice. So I am just drawing this slightly differently now. This point was O, this point was E, this point was D, and this point in front of me. So right now just concentrate on this. So I know that this side is 12, this side is 4, and later I'll show you that this side is 3. Okay. Now in this diagram, just pick up triangle OED. From this diagram, which is the same as the diagram above, but just seeing it from a different angle. So join these 3 points, O, A, and D, and make a triangle. So what kind of triangle that will be? That will be a right angle triangle because this angle is 90. So you can see that in triangle OAD now, we have a very simple relationship that OA was actually the x component, which I had written as 12, and AD was the y component, which we had written as 3, and this angle is 90. Okay. So therefore, what is the side OD equal to? OD is equal to square root of OA square plus AD square. So that in symbolic language, it is square root of AX square plus AY square. But exactly speaking, here it will become square root of 12 square plus 3 square. Becoming 144 plus 9, so that is 152 plus square. So that is just this triangle. So I think this is self-explanatory, nothing very difficult here. So I've just picked out that triangle from that rectangular box. From the earlier rectangular box, just picked out this triangle. And this is how it is. Okay. Now next I come to the slightly more difficult. And that is like this now, that again in that rectangular box, just to save on time a little, we'll try and draw it by hand. So it looks a little sloppy, but doesn't matter. So this was the triangle which I just, but with this side. This side was only. Now also I have this point E over here. So join the point O with this. Or just hang on a second, let me do a better job of this. I'll get it, don't worry. Yeah, this should be the job. So I had O, E, and D already sorted out. Now this point is E over here. So first join these 2 points. This is my body diagram, OE. And then also join O and B, which is these 2 points. So now I want you to concentrate on this triangle here. This triangle. And we're going to visualize this triangle from this side. Okay, so our line of sight is like this. We are looking from that side. So how will that triangle look? Let's try to understand. So triangle OED, this one, how this will look, and we are looking from that side. So now that triangle will look something like this. We are seeing from that side. ED will be like this. Okay. OD will be like this. And in comparison, OE, which is the third side we are trying to find out, which is actually the vector E, that one will look like this. Okay. Now, can you understand why this angle is 90? To go back here in this diagram, can you understand why the angle between this line, DE, okay, OD is perpendicular to DE? Okay, let's understand why this is happening. Because OD is in which plane? In the XY plane. Okay. Is this plane? This is the x-axis. This is the y-axis. Whereas DE is along which axis? It's along the z-axis. So DE is along the z-axis. That is why they are perpendicular. You want a slightly better explanation of this? Go back to this diagram. So you can see here OD kahan pe lie kar raha hai? OD is lying in the XY plane. This is the XY plane. That is that face of the box is lying on that face. Lying on this face of the box. Okay. Whereas D is along which line? DE over here is along this line. D is along this side. It's along the z-axis. So that's why it's perpendicular to that face. So any line that is lying on that face, on that XY plane, is perpendicular to anything which is along the z-axis. That is why in this diagram, if you join the points OD, that line will be perpendicular to DE. especially when you visualize it like this, you understand. OD is lying on this wall, whereas D is this other edge. So they are mutually perpendicular. Okay. So that is why this is happening. And OD we had just seen was equal to how much? OD was magnitude wise, it was square root of AX square plus AY square. Whereas DE, as we have seen before, was nothing but AZ, which was basically 3. And this was square root of 12 square plus 4 square. So now finally, how much is my OE becoming? Pythagoras theorem. So this is AX square plus AY square, because OD was square root of AX square plus AY square, and this is nothing but EZ square. So the vector A is magnitude becomes square root of X component squared plus Y component square plus Z component square, which in this case will become square root of 12 square plus 4 square plus 3 square, which you know becomes square root 169 or becomes 13. In this particular example, it is 13, but the general formula of the magnitude of the vector becomes like this, which is actually also a geometrical formula that if you have a cuboid of edge lengths L, B, and D, the 3 mutually perpendicular sides are length L, width B, and let's say height D, or the other width is D, whatever. Then the body diagonal is given by this geometrical formula, the square root of L square plus B square plus D square. I don't think you would have studied it in 9th, because 3D geometry was not done in that much detail, but there is a theorem in geometry also which says that the body diagonal is square root of length square plus width square plus height square. So I have done a sort of proof of that over here just by using Pythagoras theorem twice. Okay, so we will hope this is clear, and with this we come to the end of today's lecture, which is about components in 3D. So go through this section carefully through the video lecture once more, and I'll explain in detail. Okay, now final thing to keep in mind that, for example, you have something like this. Vector A is I cap plus 2j cap plus 2k cap, and vector B is, let us say, 2i cap minus j cap plus k cap. Now we can calculate A plus B or A minus B by using the same kind of method as we've done before. So this will become the sum of their x components into I cap plus the sum of their y components into j cap plus the sum of their z components into k cap. Just the z thing will be added. So as you can see, the x components are 1 and 2. So this will become 1 plus 2. The y components are 2 and minus 1. So this will become 2 minus 1. And the z components are 2 and 1. So then this will be 2 plus 1. So this will become 3i cap plus j cap plus 3. So this will be what our vector A plus B is. Okay. And in case you want to find out the magnitude of the vector A plus B, it will just become square root of its x component square. So that's 3 square plus y component square plus z component square. As you can see, it is square root of 90. Okay. Similarly, if you wanted to calculate the difference of these vectors, we would do that by just taking the difference of the components. So A minus B would be A's x component minus B's x component, like that. So here this would become 1 minus 2. This would become 2 minus of minus 1. And this would become 2 minus of 1. So this becomes minus I cap plus 3j cap plus k cap. That would be the vector A minus B. And similarly, its magnitude would become square root of x square. So that is minus 1 square, but that's the same thing as 1 square plus 3 square plus 1 square. So this time you can see the magnitude will become root of 11. Okay, so that is how we do sum of two vectors and difference of two vectors. It's just like we did for the two-dimensional system, but now we're just adding the third component. So just like we had ax plus ay, bx plus by, now we also have az plus bz or az minus bz in case we're doing addition or subtraction. Okay, people, so hope all this is nice, and go through the this thing once, the video once, for the understanding of the three-dimensional coordinate frame system. Okay, that's very important, and how we finally came up with this result, that the magnitude of a vector in 3D is given by this. And apart from that, complete worksheet 4. Now about, so just a final word here, about your upcoming test on 17th. The syllabus of the test will be up to today's lecture actually, that is up to vectors and three-dimensional components, and sum and difference and parallelogram law application, triangle law application, etc. You will also have, I mean, in the next lecture we will be starting with vector products, but that will not be coming in the test. Okay, that will be coming in the subsequent test after that. So don't worry about scalar product and don't worry about cross product just now. That is excluded from your syllabus for the upcoming test. Your test is only up to today's lecture, and today's lecture, when you see the application, it's actually very easy, because in 3D, what you had ax plus ax I cap plus ay j cap earlier, you're just adding a z component, but all the formulae are symmetrical. Just like in 2D, your magnitude was root of ax square plus ay square. Now in 3D, the magnitude is becoming root of x square plus y square plus z square and things like that. So it becomes pretty easy. So while the understanding was a little bit complicated because we have to visualize in 3D, but the application part of that part will be very easy. So what you have to concentrate on most of all for your upcoming test is your worksheet 4. The maximum difficulty level of questions which will come are the difficulty level that is there in worksheet 4. Along with that, do a thorough revision of worksheet 1, 2 and 3. And the worksheet that I give you for today, the 5th one, it will be like, a sort of a revision worksheet, because all the concepts that we've learned till date, they are going to be mixed up, but the level of difficulty will not be so much. So worksheet 4 is the critical one. If you can complete worksheet 4, including discussing your doubts and all that by this weekend with me, then you will be in a very good position for your upcoming test, because you can revise thoroughly next week and make sure that you are well prepared in not only vectors but in all the subjects accordingly. Okay, so that's it for today's lecture, guys. Wish you all the best and stay safe, and discuss with me in case of any doubts and things. All right.